Hi everybody, today we're going to be taking a look first at our Beyond the Bell review part 2, and we'll only be looking at page 1. So this time, if this page hasn't been handed out to you guys, go ahead and pause the video and make sure everyone has one. We're going to be looking at the first part, just the front page, and the second page you should be taking a look at for homework. As a reminder, you need to come to at least one lunchtime tutoring this week in order to earn the right to take the second half of your retake on Friday during class. Okay, let's go ahead and get started. So the first question reads, explain the error below. X squared plus 4x plus 77 equals 0. And then it looks like they added 4 to both sides, and then they got that x plus 2 squared equals 81. The next question, the next part of the question asks, what are the zeros of the function? So the first thing I know is when I look at this, they're clearly completing the square. And the first job is to find C and to move it to the other side. So in order to move it, they need to do the opposite. Now they're adding 77, so they should have subtracted 77 from both sides. That means that this should be a negative 77. So right there is my error. They should have subtracted 77 from both sides to move the C over. Then they found B. B was 4. They cut it in half. Let's see if they did that right. B is 4. They cut it in half. That's 2. Then they squared it. 2 squared is 4. They should have taken that 4 and added it to both sides, which they did. Okay, so it looks like the only error they really had is they should have subtracted 77. And that means that this number 81 should be different. So if I have negative 77 plus 4, it should be negative 73. So let's go ahead and do this the correct way. So this should be negative 73. So let's finish completing the square and see what the zeros are. Okay, so we have, now that we've corrected, it should be x plus 2 squared equals negative 73. All right, so the next step would be to square root both sides. And when I square root both sides, I'll get one of the x plus 2's. So that'll be x plus 2 equals plus or minus the square root of negative 73. Now right here, you should automatically be thinking, something's wrong here. That's supposed to be an exclamation point. Yeah, there's something wrong here. You can't square root a negative number. So right here we stop. If you put this into the calculator, it would tell you error, 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 because it knows there's no real number that you can square root. So right here, this indicates to us that there are no zeros. There are no real roots. There are no zeros. And that's actually the end of that problem. Okay, let's move on to question 8. Question 8 says, a quadratic equation. Well, they want us to write a quadratic equation that has x-intercepts at 4, 0 and negative 2, 0, and the vertex is a minimum. Now, this is enough information right here for us to actually graph it. So the first thing I want to do is, I'm going to write it in factored form, but I want to know what the a is. And I'm going to find a from this information right here. If the vertex is a minimum, it means it looks like this. It's a smile. The vertex is the lowest point. If it looks like this, then that means my a value is a positive 1. Okay, so that means that when I write this in factored form or standard form or vertex form, the a should be positive. So let's make sure we do that. Now remember, when we know our roots, when we put them into factored form, it'll be the opposite. So it'll be y equals a, which is positive 1, times the opposite of one of the roots, times the opposite of the other root. All right, this is what the equation would look like in factored form. And that makes sense. Positive 4, negative 4. Negative 2, positive 2. A is positive 1. The first number is positive 1. Now this positive 1 isn't going to change anything. If it were negative, it would. But since it's a positive 1, when I go into standard form, I'm just going to go first, outside, inside, last. So I'm going to continue this and multiply. Let's change to blue. First, outside, inside, last to get the standard form. Okay, so let's see, I'll get x squared plus 2x minus 4x minus 8. Well, it's almost in standard form. Standard form would mean I could see a, b, and c. So I need to combine like terms here. Positive 2x minus 4x y equals x squared minus 2x minus 8. So this is my standard form, and here's my factored form. And now we're ready for vertex form. Now for vertex form, just as a reminder, it's y equals a times x minus h squared plus k. Now do you remember what hk stands for? Of course you do. hk is the vertex. It's the vertex. Okay, so I don't know the vertex, but I do know where the roots are. And the roots are at 4 and negative 2. So if these were points, well, I mean they are points, but if we put them in a table so we could see the points, one of the roots is 4, 0, and another one is at negative 2, 0. The vertex should be in the middle. So I can actually take a look at a number line. Here's negative 2, and here's 4. So let's find the midpoint of negative 2 and 4 to find the middle. That's where the vertex will occur. So let's see, 3, negative 1, 2, 0, 1. There it is, right there. This is the middle. The midpoint would be 1. So I know my x value will occur for my vertex at 1. I know that h is going to be 1. But how do I find my k value? You guys are all saying, plug it in, plug it in. You're right. We have to plug it in. But where? Well, you have two choices. You could plug in your x value here, or you could plug in your x value here. I'm going to choose to plug it in here. So I'm going to say, okay, so I've got, let me do this in blue. I have y equals 1 squared minus 2 times 1 minus 8. Okay, so if I put that in the calculator, I get 1 minus 2 minus 8, which is y equals negative 9. Am I right? 1 minus 2 minus 8, yeah, negative 9. So that means that my vertex is 1, negative 9. So now I'm ready to put this into vertex form. Now remember, my a is positive 1. So with this information, I can fill it all in. So y equals positive 1 times x, the opposite of x, squared, the same as y. Okay. This is my vertex. So take a look. There's my a. The k value is the same. What I see is what I get, but my x value in the parentheses is the opposite. My real x value for my vertex is positive 1, so in the formula it lives as negative 1. Okay, let's move on to our next problem. All right, there she is. You know what this means. We have to find the roots. Find the number of solutions and identify the x-intercepts of each quadratic equation using any method you choose. Now I'm going to go ahead and be pretty bold and tell you that for all of these problems, I want you to always do this first. The first thing I want you to do is scan and see if it's worth it to complete the square. I'll tell you what I mean in a second. Complete the square. So the first thing I want you to do is seek out any problems that look like they're ideal for completing the square. Once you've weeded those out, then you're always going to follow this routine. First, can I factor it? And then if you can't factor it, all right, it's time to bring in the big guns. It's time for the quadratic formula. Okay, so the first thing I'm going to seek out is, are there any problems here that look like they want to be completed by the square? Okay, and you know what those look like. They should look like problems where I already have something squared and a number. And there happens to be only one of those here. Do you see it? Is it A, B, C, or D? Which one of these problems is begging to be solved by completing the square? Do you see it? I hope you do. It's A. A is the only problem that wants to be completed by the square. And you can tell that because you already have the binomial squared right here. This is just begging to be solved. In order to do this and make it look like a completing the square problem, what I need you to notice is this is really far down the road in completing the square. When we solved it, many of you complained, this is so many steps. You know what, this is towards the end of those steps. This is like step 6. It's almost there. It should be something squared equals a number. So I need to move this minus 9. So I'm going to go ahead and add 9 to both sides. And when I do that, I get x plus 2 squared equals 9. Now right here you should feel right at home. I square root both sides, and I get x plus 2 equals plus or minus 3. Now this is where a lot of you made some errors, so let's make sure we do this right. We need to get the x alone. They're adding 2, so I will subtract 2 from both sides. When I subtract 2 from both sides, I get x equals negative 2 plus or minus 3. Notice that the plus or minus belongs to the 3, not the 2. Did you see my negative just got dropped? There it is. Okay, so negative 2 plus or minus 3. So now let's find the roots. The roots are going to be x equals negative 2 plus 3 and x equals negative 2 minus 3. What are those going to be? Easy. One of my roots will be 1, 0, and my other root will be negative 5, 0. There's my answer. Okay, so letter A was the only problem that I was going to use for completing the square, and that's only because it was already factored. It was ready to go. For B, C, and D, we're going to check first, can I factor it? And if not, we're going to the quadratic formula. So here we go for our first problem. For letter B, I'm going to go ahead and make this separated. If not, we're going to run out of space. Okay, for letter B, A is 2, B is negative 2. That looks so ugly. Let's fix that. All right, let's try again. A is 2, B is negative 2, and C is 5. Let's check and see. What multiplies to 10 and adds to negative 2? Are there two numbers that would satisfy this? 5 and 2, 10 and 1. No, this cannot be factored. That means we're putting this in the quadratic formula. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. All right, let's put in our values. Negative b is negative 2. There's my b again. A is 2, c is 5, and a is 2. All right, so I'm going to put these values in, and remember I put this part into the calculator first. So you're going to put negative 2 in parentheses squared. I have my calculator here, so I'm going to do it with you. So I have negative 2 squared minus 4 parentheses times 2 parentheses, put in your 5. It should look identical to what's in the yellow circle, especially making sure that those are in their parentheses. All right, when I push enter, I get negative 36. Did you get negative 36? I did too. Okay, so let's go back to our black pen here. So we get x equals negative 2 is positive 2, plus or minus the square root of negative 36, all divided by 4. Now, this should bring you back to what happened up here with this problem. Remember, we had a square root of a negative number, and what did that imply? No real roots. We stopped working. And I hope you stop working here too. Why? Because of this right here. This has no real roots. There's no need to simplify. Your work here is done. Okay, let's move on to letter C. First step, let's see if we can factor this. A is 1, B is 6, and C is 9. Okay, what multiplies to 9 and adds to 6? What are those values? Yeah, this can be factored by 3 and 3, both positive. That means that 0 equals x plus 3 times x plus 3. Now you guys are so adept at this now, you don't even have to write out the equations using the zero product property. You know the roots are the opposite in factored form. So you know the roots are negative 3, 0, and don't you dare write it again. Negative 3, 0 happens twice, right here and here. How many roots does this have? Don't you dare say twice. It has one root. It crosses only at negative 3, 0. just because it happens twice in the equation does not mean that it occurs twice here. It's the same number. Both are -3. So this problem has one root. All right, last one, letter D. Okay, for letter D, remember our first step is to check to see if we can factor. So we find A, B, and C. There's a problem here. A is 1, B is -8, but what's C? It's not 9. You need to subtract 9 from both sides first, and we get x squared minus 8x minus 9 equals 0. Now we can see A, B, -8, and C. And we check, is this factorable? -9 and -8. What multiplies to -9 and adds to -8? It is -9 and +1. Yay, it's factorable. So that means that 0 equals x minus 9 and x plus 1. What are the roots? They are the opposites. All right, let's see. 9, 0, and -1, 0. This has 2 roots. Yay! Okay, so my answers here were all my boxed answers. So, oh, we forgot to write 2 roots here. 2 roots. So remember, for this first problem, number 9, you have to tell me 2 things. You have to tell me what the roots are, and you have to tell me how many there are. So they are 1, 0, -5, 0, and there are 2. There are no real roots. There's 1 root. There are 2 roots, and then identified where. Guys, you're going to have to study number 9. It's worth a massive amount of points. You have to be able to do number 9 to get all of your points you need for the Beyond the Bell. So start studying these, and remember, it takes work at home as well as work at school to really master this stuff. All right, I just wanted to show you the back page. You know what it is. There it is, the word problem, okay? The terrible word problem. I'd like you to really try this one at home. It's not homework. It's not a sign. I'm not going to check it, but you should try it. Go ahead and give it a go. Next class, I will be doing this one in class. All right, guys, let's shake it off. We did a lot of math right there. I'd like you to turn to page 44, and we're going to play a little individual game. Now, as you guys know, you're going to be taking a circles quiz next class, and I'm going to be asking you questions particularly around, can you write the equation of a circle, or can you see what the center and radius are of a circle given the equation? So on page 44, what we're going to do is I'm going to give you time to do a problem, and then I'll reveal the answer. Now, I give you permission right now. I'm telling everybody, you have my permission to work with the person who's sitting next to you. But, there's a big but here. Please make sure that you give yourself the opportunity to try it on your own first. It might be worth it to try and then ask, or try and then check answers, okay? So give yourself at least 15 seconds of quiet time before you reach over and check in with your neighbor. Okay, here we go. I'd like you to try question 1, and this should take you no more than 15 seconds. All right, good luck. Do you have an answer? I hope you do. All right, remember, for a circle, the opposite of the x and y go in for the h and k, and the radius must be squared. So right off the bat, any of these that have the radius of 2, I can just cross off. It's obviously not A. Okay, so that means it's B, C, or D. Which one has the opposite for 4? So it's got to be a -4. And the opposite for y of -3 would have to be a +3. Yes, ladies and gentlemen, the answer is B. Congratulations, you did it. All right, moving on. Okay, for question 2, I'd like you to go ahead and see if you can find the answer for equation 2. And I'll give you 30 seconds for this one. Ready, set, go. $15 more seconds. You almost there? All right. Okay, so I bet you got the center for this circle. it's at -2, -7. So that means that in my H column, I should see a +2, and in my Y column, I should see a +7. Okay, so right off the bat, I know it's either A or D. It is not C, it is not B. So the big question here is, what's the radius? Is it 1/2 or 1/4? The question is, what's the radius on this picture based on the scale? When I look at the scale here, I can see that this is 1 and this is 2. So that must mean that 1 square is worth 1/2. If that's the case, then that means the radius is 1/2. But what is 1/2 when you put it into the equation of a circle? Remember, this value isn't r. This value is r squared. So what is 1/2 squared? It should be 1 squared over 2 squared, or, bing, 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 1/4. The answer is A. All right, good job, guys. All right, for question 3, I'm actually going to ask you to pause the video, and then when you feel like you're ready to reveal the answer, we'll go ahead and do that. So let's move down to number 3. Go ahead and pause the video and give it a try, and unpause it when you're ready to get going and see the answer. All right, let's see how you did. For this question, it says, the equation of a circle is centered on R, so this is the center, and it has a radius RS. So the question is, if I have the center is at at 4, I almost said -4 there, +4, +7. So I know what the center is, I know what H and K are, but what's the radius? What is this length? Well, if I can't see this length, I better find it. I could find it if I drew a triangle. Oh, did you guys think of this? Oh man, I'm crossing my fingers and hope you did. All right, let's see. The length of the base is 3, and the length of the height is 4. So if I use the Pythagorean theorem, 3 squared plus 4 squared equals the radius squared, I get 9 plus 16 equals the radius squared, or 25 equals the radius squared. What's the radius, guys? It's 5. Okay, cool. So if I found the radius now, my radius is 5, what would that look like in an equation of a circle? Well, for sure, I know I'm going to have the opposite of 4 and the opposite of 7 in there. So it should be -4, -7. And my radius should show up inside the equation as a 25. Ladies and gentlemen, the answer is D. Good job. Okay, turn the page. We got a couple more to do. All right, so now that you know how to do question 4, I'm not going to show you how to do it. Go ahead and pause the video, and when you're ready, unpause it, and let's see what the answer is. All right, let's see. You should have gotten that the radius was at -3, -6, and the radius was the square root of 125. That means that the answer is, did you say C? No? Good, because the answer is D. Excellent work, guys. Let's move on to question 5. All right, go ahead and pause the video and unpause it when you're ready to reveal the answer. This was an easy one. I hope you were all making a lot of noise. Let's see, the opposite of +7 would mean that it would be at -7. The opposite of -8 would mean +8. The square root of 9 is 3. So let's see which one of these matches my correct answer. It is C. Woohoo! Good job. I can tell you all got it right. All right, the last problem is the big one. Question 6. I want to know, can you find the center and can you find the radius? Now, I'm going to ask that for this one, you not talk to your neighbor. That's right. Say goodbye. Don't talk to them. For number 6, the only resource I will give you is your packet. So please try to do this one on your own. Unpause the video when you're ready to see the answer. Okay, let's see how you did. You should have organized this to be x squared minus 18x, and then had your y squared plus 12y, and then you should have moved the 68 over, so this should have been your starting point. When you completed the square, you should have taken negative 18, cut it in half, that's negative 9, squared it, that's 81. Over here for completing the square, you should have taken half of 12, that's 6. 6 squared is 36, and then added that to both sides. When you factor, you would have gotten x minus 9 squared plus y plus 6 squared equals 49. That means the opposite here would be 9, the opposite here would be negative 6, and my radius would be the square root of 49, or 7. That means our answer is D. All right, excellent work, guys. Let's turn the page. All right, for this last problem, we did one of these in our homework, but just as a reminder, in order to find the center and radius of this problem, you need to do the exact same thing that we just did, except, I hope you're noticing a problem here. This should be x squared and this should be y squared, but it's not. It's got these 5s in front of it. How would I make this look like a typical problem? I'd have to get rid of that 5. Now the 5s are multiplying with the x squared and the y squared, so you should do the opposite. So go ahead and divide all of those values by 5 and then complete the square. When you're ready, unpause the video and we'll see our answer. Okay, let's see how you did. I'm going to go ahead and move this guy over a little bit. If I divided every single term by 5, including that 0, okay, so every single term on both the left and the right, this is what I would get. X squared plus y squared minus 10x plus 4y plus 20 equals 0. Now if I organize myself into my x's, put my x's in one location, I put my y's in another location, and I put my constants all on the right. I complete the square. I add those values that I completed the square to both sides, and then I factor. This is what you should have gotten. 9. This is what you should have gotten if you solve this correctly, meaning my center is at 5, negative 2, and my radius is 3. Now there's only one graph that is in this quadrant with this small of a radius, and that's graph A. All right, please make sure you study these 3 pages for your review, and remember you'll be taking a quiz next class. Okay guys, it's time for a task. All right, I'm going to give you a task. I'm going to give you a couple hints. You and a partner, that's right, a partner, you and one person in the class are going to have to pair up together and turn in a task called the gingerbread man. So please turn to page 43 and then we'll get you into groups in a moment. All right, so here's how this is going to work. On page 43, there's a problem called the gingerbread man. Now I don't want you to rip this out. This is just meant to be the place for you to read the problem, but all of your math work, a diagram, and any thoughts that you have in figuring out the answer to this question will have to go on a separate sheet of paper. So let's get organized. The first thing I'd like you to do is let's think about the problem. Once we're done thinking about the problem and I've given you some hints, we will split into groups of 2 and I'll tell you what materials you need to turn in order to get credit for this very important problem. Let's read it first. So it says, a bakery firm makes gingerbread men, each 14 centimeters high. So you can see that right here. So from head to bottom, because I guess it doesn't have, anyway, I don't know what a gingerbread has, but from the top to the bottom, it's 14 centimeters high. It has a circular head and a circular body. Now they're creating a gingerbread logo, and they need help to find the equations of these gingerbread men so they can put them into the computer. Someone has already determined the equation of the body of the circle. Okay, so the body of the circle goes with this equation right here. But here's the problem. That person quit, so they need your help to find the equation of the head. All right, so here's what you guys are going to need to do. You're going to need to first use this equation to find the center and the radius of this circle here, of the body. Now you know that if you put that radius value here, you will find some measurement. And, well, actually that's the extent of the hint I'm going to give you. So when you find the equation for this circle right here, I recommend you look at the radius in this direction and maybe even here as well. Okay, I've said too much. All right, here's what you and your partner are going to need to get. You need one piece of loose leaf paper. I have graph paper, I have blank sheets of paper. You can choose. You need one piece of paper, not two, just one. The second thing you're going to need is on your paper, you will need to have your names, obviously. You will need to have a picture of your snowman. Don't put a hat on him. I just did that for fun. You will need to have some math. And you will need to have some words. Now, let's make sure that you understand what the question is asking. I want to know what is the equation for the head of the circle. And here's the big deal. I want to know how you found it. So you're going to tell me the equation for the head, and you're also going to tell me how you found it. Now, here's where you ask, how much time do I have, and when is this due? This is due before the end of class, and we're only going to give you 15 minutes to answer. 15 minutes, okay? So you need to find a partner in the classroom, and then as soon as your teacher says so, they'll let you start, and once those 15 minutes are over, you're all going to need to turn in your papers, and I actually have some more notes for you. So go ahead and get started, and I'll see you in 15 minutes. Did you finish? Did you turn in your work? Remember, you're only turning in one piece of paper, and both your names should be on it. You should not have ripped out page 43. All right, let's go ahead and move on. Okay, so here we are on page 50, and all we're going to do is stick our toe into the notes of next class. So on page 50, the first thing I'd like you to do is read this question with me. It says, how many times can a circle and a line intersect? Illustrate your response with a sketch. Okay, I'm going to show you the ways that they can intersect, and you draw as many pictures as you need to. Okay, one of the ways they can intersect is the way I'm showing you right now. The line could be completely far away from the circle. The circle and the line never intersect. Okay, so that's one picture you could draw. Another picture is they could cross twice. So they could intersect over here and over here. So a line and a circle could intersect twice. But there's actually one last way that's kind of interesting, I think, and it's when a line is called tangent to the circle. Now, I want you to notice how I'm really carefully taking that line and just touching it right there. Okay, when this happens, this is called the line being tangent to the circle. And when this happens, the line crosses the circle exactly once. It's called at the point of tangency. You don't have to know, that's just fun to say. So this is an example of what it would look like if the line intersected once. So you should have three pictures. A picture where the circle intersects the line never, a picture where the line and the circle intersect twice, and a picture like this where the line and the circle intersect exactly once. I told you these notes would be short. Go ahead and turn the page, and all we're going to do is the you try number 1. That's it. So on page 52, let's go ahead and take a look at this problem. All right, the directions say find the points of intersection between the line, y equals 2x, and the circle, x squared plus y squared equals 45. Now, it could be that they have no points in common. They could have 1 point in common. Or they could have 2 points in common. I wonder what it'll be. Oh, the mystery. Okay, let's see. All right, what we're going to do is we're going to take this line, and we're going to take this equation and substitute it into this equation to see how many points they have in common. So I'm going to take this line and substitute it in here. Now, it just so happens that I know what y equals. Y is equal to 2x. That means if I want to substitute anything in for the place of for y, if I want to substitute anything for the place of y, I can substitute it with 2x. So what I'm going to do is I have x squared plus y squared equals 45. That means instead of writing y, I'm going to put 2x in its place. So I'm going to take this 2x, and I'm going to put it here. So, you know, if I really look at this, it actually says x squared plus y squared equals 45. All right, let's solve this. I get x squared plus, what is 2x squared? What is 2x squared? 2x squared is 2x times 2x. What's that equal? I hope you said 4x squared. All right, we're almost there. X squared plus 4x squared, that's 1x squared plus 4x squared, that's 5x squareds. They're multiplying by 5, so I'll divide by 5. So that means x squared equals 9. I feel like we're getting somewhere. They're squaring, so I square root. That means x equals plus or minus 3. Now, in the previous chapter, this meant something different, but I want to make sure you know what this means. This means that this circle and this line intersect at 3 and -3. But the number over here is not 0. How do I know what it is? Well, I'm going to use either this equation or this equation to figure it out. Y equals 2 times x. Let's put in 3. Okay, if I put in a 3, I get out 6. That means that at 3, 6, that point exists for both this circle and this line. And you know what? That works for either one. If I had put the 3 into this equation, I would have gotten out a 6 too. In fact, I'll prove it to you. It is x squared plus y squared equals 45. 45. If you had chosen to put the 3 in here, you would have gotten 6 too. That's because this point works for both the circle and the line. So this is 9 plus y squared equals 45. If you subtract 9 from both sides, that's a 45. You get y squared equals 36, square root both sides, y equals plus or minus 6. Now, what this means is that for both points, for both equations, if you put in a 3, you get out a 6. Now, the other way that this could work is instead of putting in a positive 3, I'd put in a negative 3, and you can kind of see that it was plus or minus, right? A negative 6 would have come out. Now, what does that mean? Well, take a look at the picture. Let's plot these points there. So if I go over 3 and up 1, 2, 3, 4, 5, 6, or if I go to negative 3, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, these 2 points are special points. They're points that exist on both the line and the circle. Now, since I know that they work for the line, I'm going to make the line purple. So my line is y equals 2x, and I know these points go through that line. So I'm going to, as carefully as I can, draw a line that goes through those 2 points. Oh, I didn't do a great job. Okay, so this is the line y equals 2x. I can connect those points and make a line because, well, I know that the line goes through those 2 points. I also know that my circle, let's make the circle orange. I also know that my circle goes through those points. So my circle has a center at 0, 0. So here's my center point. And it has a radius of the square root of 45. And that's a little bit more than 5. 6. It's 6 and a little bit. 6 and, let's say 6.8. So I'm going to go over 6, 1, 2, 3, 4, 5, 6 and a little bit. 1, 2, 3, 4, 5, 6 and a little bit. 1, 2, 3, 4, 5, 6 and a little bit. 1, 2, 3, 4, 5, 6 and a little bit. And I'm going to connect those points into a circle. Now, if you really study this, you can tell that for my all the points that create a circle, these two blue points are special. And of all the points that make the points for this line, these two blue points are special. The blue points are the ones that they have in common. That's why they worked for both equations. So this is actually where we're going to be headed next class. We're going to be looking at what happens when a circle lives on a graph with other functions, and how do we find those points that they have in common. All right, great job, guys. Last step is your homework. Okay, your homework tonight is on page 48, so go ahead and turn there. And what I hope you notice is that this is only part of it. So for page 48, in looking into where we're going, I'd like you to do the bottom half and the second page, so page 48 and 49. It's one question. It asks, for these two circles, if you graph them, what's the distance between those circles? Go ahead and show a picture of them. It's basically you have two circles, graph them, and what do they look like in relationship to each other. Honestly, you could probably do this in class. All right, I hope you have a great day, guys, and I'll see you next class.